Here we go.
The following takes place between 4 p.m. and 5 p.m. Events occur in real time.
So this is the story of Jack Power, we'll call him, or DBA. And he happens to be on call. But he's decided to have a date night with his spouse. So they arrive at the restaurant at 4 p.m., of course, as alluded to in the intro here. And they go to the bar to have a cocktail and just start having a nice conversation, as one might do with their spouse. And if any of you have been on call, you've probably been interrupted by issues more than one time at dates or functions or anything like that. So right around 4:10 p.m., a connection storm happens in production. So let's go ahead and simulate that. I just have a couple of commands here that will simulate a connection storm for me. Okay. So when a connection storm happens, we will see that alert in Ops Manager after about a minute or so. Ops Manager will come up, fire that alert that connections has gone above a certain amount of whatever our predefined amount was. Okay. So in this case, this isn't going to be of much help to Jack, who's sitting having a nice conversation with his spouse right now, unless we do something else, unless we have a third party intervene here. So at about 4:11 p.m. or so, after that connection storm has happened in production, Jack's phone lights up. And Jack doesn't necessarily have Ops Manager on his phone, of course, but he does have his chat client. And he sees a new channel appear in the chat client, as we see up there. And MongoBot sees that alert as well, and it takes the following actions. It will create a new ticket in the ticketing system, so whether they're using Jira or ServiceNow or whatever their ticketing system is. It will open a new chat channel in regards to that ticket. It will invite the appropriate members of the team to that chat channel. So it can invite the DBAs, the systems admins, the application developers, anyone who has a stake in working with that particular issue or that alert. And it'll also post some relevant information to that channel, including a link to the ticket that was opened, a chart of the connections, and a chart of the op counters, in this particular case, due to a connection storm. So let's see that in action. Here's my chat client. Here's that new channel that was created. And lo and behold, here's a brand new channel. Here's the raw Ops Manager alert data that we see, just for informational purposes. A link to the ticket number. A chart of the connections. We see the connections starting to kind of go vertical here, so we are able to see what's going on graphically and instantly, as well as the chart of the op counters. So we see a brief spike in op counters, but they seem to have come down at this point. So we'll see another example of that in a second here. So Jack goes into this chat channel and looks at these charts. He doesn't really see anything wrong here per se, aside from the number of connections, but still needs some more information. So he decides he wants to see, well, what are the queues like on the server? So Jack will ask MongoBot for the queues on host node 1. By the way, I make a lot of typos, and they may be contagious. Just as a fair warning, you may make more typos after you leave this session here. So MongoBot instantly replies and says, there's no queues on server 1. Well, what's going on here? Well, let's just run a health check. Let's run a health check on the whole replica set. So you can see on the chart there, we do show what the replica set is for that particular node where we have the connection storm. So we're just going to ask MongoBot. Oops, there's one of them typos again. So we'll do a whole health check, and we just saw a whole slew of stuff fly by here, and at the high zoom level, it looked like, you know, almost too much information to read. But so we ran a health check here. So what MongoBot does is for each node in the replica set, post the health check information that we want to see. In this case, the name, what the replication status is, the version, you know, ping, the last restart time. We can see the op counters here now because we have more up-to-date information. We see that spike happen when all those connections were established, but we also, based on the fact that we don't see anything else going on, can kind of deduce that a bunch of connections were established, but not much else is going on. Also, there's no queues, and of course, we can't plot replication lag on the primary. So on the secondary, you can see here, you know, op counters is nil, connections is stable, lag is around 10 seconds, so not anything that's too over the top. Same as the case with node 3. So aside from a bunch of new connections, the cluster seems healthy. So Jack can talk to that in the channel and say, you know, cluster looks healthy, and basically inform other people in the channel who are also saying this information, what's going on and what his opinion is of things. In addition to that, you can see here periodically, MongoBot will repost those two charts that it posted when the alert opens. So we see a chart of connections, which is still way higher than it should be in this case, and op counters. So you can code whatever you want based on whatever alert here and you know, plug in rules and charts to fire. I just chose these two for a nice example here. So Jack basically says the cluster looks healthy. You know, he's kind of looking down and chatting with his phone, and his spouse says, "Why are you paying attention to your phone and not me?" No one's ever heard that before in this room, right? And, you know, Jack's reply is, well, you know, otherwise we might have to abandon the data and I'd have to go home and VPN in to the network to diagnose this. So at about 4:25 p.m. or so, the app dev team discovers that they had a bug in a drop they just put into production, and they were accidentally creating a bunch more connections than they should have. So the decision is made to roll back the code. Fair enough. The problem is these connections would still be established on the server if you just killed the app servers. So in order to kill these connections, Jack is asked to restart the servers. So is his date going to be ruined? Well, no. He can restart the servers right here from the chat client. So once again, I'll just say restart REPL set, prod test. And here we go. So what's going on here is MongoBot is interfacing with the Ops Manager API and doing a rolling restart of these servers. So if we go to our Ops Manager screen, hit a refresh, we can see there's deployments happening. So this is through the API on Ops Manager. So I go through, I list the servers, we take each secondary down, bring it back up in order, and then finally restart the primary. So this does take a few minutes. Fortunately, Jack can monitor it a little bit from his phone because the chat client, MongoBot, tells him what's going on at this time. So we've restarted node 2. Now we're restarting node 3. And of course, node 1 would be the last one since it was the primary. Once that's complete, not only does Jack see that it's complete, so does everyone else in the channel, the systems admin, the app developers, the managers, whoever else is invited to this chat channel. So it gives you that ability to not only take action from the chat channel, but to disseminate all of that information immediately to all of the people working on this issue. So it's going to lower that cycle time. And in addition, now that it's up and running, Jack's going to run one more health check just to make sure. And there we go. So we can see the health check coming out, and apologies for the slowness. I have way too many things running on my poor Mac here. So you can see basically that, things have restarted recently. Sometimes the last restart takes a while to come up, but you can see the last ping was at 41 after the hour on that particular node. So now everything looks healthy. The number of connections on node 1 is now starting to fall, which you can see on the very right side of the chart there. Queues are fine. Everything looks healthy within the replica set. So Jack informs everybody via the chat channel if you want, even though they've already seen it, restart's complete. So let's restart the app. And then Jack can watch the chat channel, all the while still having that conversation with his spouse and probably saving his marriage, at least saving an argument anyway. So MongoBot saves the day, MongoBot possibly saves the marriage. Okay. So at 5 p.m., the app team responds, everything looks good. Jack can run another health check. Everything's good, the issue's closed, life is good. One more quick thing to demo. A few days later, the application team has decided that they want to do a minor version upgrade. So we are currently in production running 3.4.10. And we want to upgrade to 3.4.15. So at that point, this issue's been closed, so that channel might not exist anymore. But we go into the MongoBot channel here. And you can see if MongoBot doesn't understand you, it's going to post a snarky reply to you. So Jack wants to upgrade this replica set. In order to do that, this one I'm going to have to copy and paste because there's way too much opportunity to make a mistake here. So there we go. I'm going to upgrade the replica set prod test to 3.4.15 enterprise. So what happens is we start obtaining a lock. And in this case, we have to wait so long for the upgrade to happen because the way upgrades work in Ops Manager is you pull the Ops Manager automation config, you set the version on each of the MongoDBs and post it. Ops Manager on its own calculates the plan on how to get there. So we can see that happen over here. That actually went very quickly because I've done this several times. So it's So what happens here is the MongoBot polls those servers and makes sure that they are up and running with the correct version before reporting that it completed. And it gives it, you get so much time, in this case 120 seconds to complete. Typically, you'll see that complete once these timers over here, the 29 seconds ago, roll back over. So it's probably, there we go. So the upgrade's complete. So there we go. Jack just did an upgrade from a chat channel on his phone while binge watching something on Netflix, not even having to get off the couch and pull the laptop out. So voila. So that is the power of MongoBot and integrating your chat system with Ops Manager. Okay, so let's go ahead and talk about the agenda here. First we're going to introduce MongoBot and have a little talk about that. And then, of course, we'll talk about the Ops Manager API. MongoBot relies heavily on this API in order to accomplish all of this. Ops Manager webhooks. So when an alert fires an Ops Manager, we can actually tell it to send that alert back to us, i.e. the MongoBot, and take the action that we want to take on that alert. Finally, the chatbot, and there's a lot to cover there, including the architecture, the chat language that's been invented here for this, and several other things. After that, we'll take a little break, and then in the second half of the session, we'll talk about responding to user requests for information, i.e. show me the connections, do a health check, show me the queues, and for actions, upgrade, restart, etc., things that we saw in the demo just a few moments ago. In responding to alerts, in this case, we created a chat channel, we file a ticket, we associate all of these together so that that other piece that we saw can periodically post updated information to everybody to see. Inviting others to the channel, and then, of course, posting useful data, hopefully useful data to the alert channel. And then finally, MongoDB, which is actually the piece that wakes up every so often and reposts that information. And, of course, other functionality that you may want to add in to that daemon as well. Okay, so what is MongoBot? Well, MongoBot is a web server that we use to interface with Ops Manager and allows you to interact with MongoDB and other systems. So this isn't unique to Ops Manager. You can integrate this with other tools you may have. If you have internal monitoring or New Relic, Sumo Logic, whatever, anything that you can interface via API with, you can integrate into this chatbot. It allows you to interact with those from any device. So your laptop, a tablet, your phone, I suppose even a watch if you can get a chat client running on there and type on that tiny keyboard. So what can MongoBot do? Well, it can automate the handling of Ops Manager alerts. As we saw there in Ops Manager alert fires, we create a channel, we take all that other action for you to allow the whole team to collaborate in near real time over what's going on. Of course, enable collaboration. Retrieve information from within your chat system. So we're sort of using the chat system as the user interface in this case. Finally, we can carry out actions that used to require a laptop and a VPN connection. So now we can do this in real time on whichever device you happen to have handy. So why should we use the chat client as a UI? Well, it's a familiar UI. I mean, everybody uses chat. Most of us use Slack, actually. You have that flexibility to run that from any device that supports your chat client. Ease of information sharing and collaboration, I talked about that. The whole team sees those charts in essentially real time and can make up-to-the-minute decisions. So nobody has to go into Ops Manager and copy a chart and paste it to a chat channel for everyone to see. You can just go ask the chat itself for that chart. So you can create processes to automatically provide info on a timely manner to the entire team. As we saw with the MongoDB there, reposting that chart of connections and op counters every few minutes after the alert was opened. So I think this is the future of DBAing. Who wants to be tied to the laptop all the time? In the distant past, you had to drive into work to fix even a minor issue. And then along came VPN connections. You'd still have to pull that laptop out, VPN in, maybe tether to your cell phone, interrupt your dinner with your spouse while doing all that at a cocktail table. It probably wasn't very pretty. But now there's MongoBot. You can do it from a laptop or a tablet or even your phone if you wish. Okay, so what do we need to implement this whole architecture? There's a lot of moving parts, most of which are kind of stock MongoDB parts, and then there's one key part of the MongoBot that I'll share with you at the end of the presentation. So, of course, we need a knowledge of the MongoDB Ops Manager API. So how many of you have used Ops Manager, and how many of you have interacted with the API programmatically? Okay, so that's good. So that's one thing that you, if you haven't done a whole lot of, definitely read up on our documentation for, because this very heavily relies on our API. A web server, and in our case, it's just this Python program, MongoBot. A way to interact with the user via simple chat language. We saw that MongoBot connections host node 1, that sort of thing. The ability to make Ops Manager API calls to get information and to make changes to those deployments. Potentially a way to interact with a ticketing system to create and modify tickets. So whatever your ticketing system is, hopefully you've got an API hook into that allow you to do this if you want automatic ticketing to be part of these alerts. interfaces to other internal systems you may want to use. Once again, if you're running a internally grown hardware monitoring system when there's a connection storm, maybe you want to post raw TCP/IP connections. Maybe you want to post the amount of network traffic going across or something like that. So if you have that ability, you could certainly add that in as well. Oops. Okay. So let's talk about the Ops Manager API. This I lifted right out of our documentation. I don't necessarily care for this sentence, but to be consistent, I put it in the presentation. The Ops Manager API follows the principles of REST to expose a number of internal resources which enable programmatic access to Ops Manager features. Also allows programmatic access to Ops Manager data, which is almost more important in this case, especially when we're trying to draw charts within a chat client. So the API has the following characteristics. We use REST methods such as get, put, post, etc. JSON, of course. What other format would we use here at MongoDB? The API accepts data and returns data in the JSON data format. Digest authentication, so we can keep it secure. So all calls have to be authenticated using a user ID and a token. So, and here's a link to the Ops Manager documentation if you wanted to bone up on some of those concepts. So calling the Ops Manager API. Well, we have a specific endpoint for each type of request that we issue within the API. So for example, here you can see we're calling, Ops Manager /API public. And in this case, the endpoint is groups plus the group ID plus the specific endpoint within the group, which could be things like hosts or alerts or whatever other endpoints we offer within a group. We have to pass in the user ID and token in digest authentication. So here's a curl example of that. curl-u, user : token. We can add a query parameter of pretty equals true to pretty print the JSON if you want to read that. Some of these can be read in human format. Some, like automation config, are quite unruly and are really only intended to be accessed via machine. So let's see an example here, and I'm actually going to pull that up in a DOS window here. Once again, I'm going to copy and paste due to my extreme ability for typos. Let's get out of that shell. Okay, so I just called this endpoint in the REST API here via curl. So you can see the command. I'll highlight it for you so you could hopefully see that a little easier on screen. I don't know how well that renders there. But basically, I'm issuing the curl request, passing in my user ID admin at localhost.com, passing my token, and then the endpoint I'm hitting up in this case is groups, the group ID and the hosts, and then passing that pretty print true onto the end so I can actually look at this. And I find this invaluable. In fact, I won't bore you with the details, but I have a whole file that I use that I keep open at Sublime all the time that's got about 50 different REST API commands so I can check out how things look when I'm seeing if a field exists in a particular command or not. So that's how we call the API. And then as far as what we return, let's go back to the presentation. So there's that example, curl. And I don't know if that's any easier to read than it was in the terminal, but that's basically the same command there. So anatomy of a response. We have this links section that usually is the first thing returned. So you can see that up here. The first value, there's always a self, meaning here's the endpoint you called. So if I were to just call the groups API without anything on there, I'd get a whole list of things under groups I could call, including this endpoint of hosts, or I could call alerts, I could call users, those sorts of things. And then a results array. In this case, I hit the hosts endpoint, so I have an array of hosts. And each of these is a document that contains whatever fields that Ops Manager provides to you. You can see here we have a good amount of fields provided to you, somewhere along the lines of 35 different properties for each host. So we have 1, 2, 3, 4. And at the very end, a total count of the results, 4. And you might expect that if we go into Ops Manager, count our hosts real quick. Look at that, 4 hosts. So that's basically programmatic access to these hosts and information about them. So some calls to the API return data in a slightly different format, but the concept is the same. You get this JSON back. It's very well documented in our REST API documentation, how to get that data back. Okay, so the next thing, Ops Manager Alert Webhooks. This is sort of the meat in the sandwich here, or the secret sauce almost that makes it work. When an alert fires in Ops Manager, we need to send that to our web server so we can take whatever action we want to take for that specific alert. So it sends those in via REST API and, of course, JSON. You can set this in the settings sections under Webhook Settings and then set that each individual alert to send to this webhook. So I'll show that to you in Ops Manager real quick. So we go into Settings. Webhook Settings, and there we go. So there's the web server I'm using. I run everything localized on this machine, so this is actually coming from a VM out to my laptop here. So you have a URL. You can also have a secret, and in our case, we don't. There are no secrets. Then if I want to send a specific alert to my webhook, then I have to go into Alerts. And maybe I want to say, the backup agent is down or something like that. I can just edit that, come down here. And scroll down and add webhook. Oops. Sorry about that. That flew by a bit quickly there. I clicked when I shouldn't have. Let's do that again. So we add webhook. There we go. So now every time an alert's fired for backup agent is down, it will also go into the MongoDB Bot alert router. And we can take whatever action we want to take in that particular case. Okay. So, as I'd mentioned, Ops Manager will send alert. You can take the action you want to take. And there's just a screen grab of that webhook settings there. Okay, so now that we're getting more and deeper into things, if you do have questions, feel free to ask at this point during the presentation. I built in some time for those questions. So the anatomy alert of an alert. What is sent into my webhook that I can take those actions based on? Well, typically we'll have a type name, which is the type of alert that's sent into us. An event type name, which is specific to that type name, and we'll see an example in a second here. In this case, host metric, the event type for that is outside metric threshold, which is almost always the case for these metrics. Connections is above X, replication lag is above Y, so on. Those are all metric type alerts, but you do have other alerts for things like storage or, agents being down, hosts down, restarts, etc. Current value, which is a document with 2 fields, the number that was measured by Ops Manager that triggered the alert, and then the units, raw in this case, but it can be things like percentage or in megabytes, gigabytes, etc. So here's an alert right here for a connections alert. We can see the things in red, our current value. We had 21 connections. Outside metric threshold was the event type. The type name was host metric and the metric name that we exceeded to fire the alert was connections. So we have all that information. Now we can take action on it. In this case, open the channel, file the ticket, post some charts, invite people, etc. Okay, so try not to be too scared of this chart. I might actually have to come down and point to a couple of things here. So there's two things within MongoBot. There's the interactive piece that we saw when our DBA Jack Power was interacting, asking for health checks or queues on servers or replica sets. And then there's also the alert piece. So basically, user requests come in from the right side of the screen, from the chat system. And then they come into that chat request router we see on the second piece. I think I'll come down here just so we can see. So I'll initiate a request from the chat system. It'll send that request into our router where we have rule plugins. So I have an individual rule for each item. So I have a rule for he's asking for connections. I have a rule for he's asking for replication lag. I have a rule for each one of those. We have a bunch of utilities that we put together to make your life easier. You can also pull from other systems, as I had mentioned before. So if you're using internal monitoring, New Relic, Old Relic, Ancient Relic, whatever, you can pull that in. Then we call the chart maker in some cases to generate those charts. Those are saved off as files. And the second piece of MongoBot is just a simple image web server where we post the chat message back to the chat client and allow that item to be pasted into the chat. I guess I'll go over here for the other piece, not to ignore you guys on this side of the room. So an alert's slightly different here. So MongoDB, something goes out of spec. We have a bunch of connections. Ops manager sees that, posts the webhook, posts the alert to the webhook. Those are routed to the same sorts of rule plugins. So each rule is sort of the same thing. It's just two different functions, one for a chat request, one for an alert. And then the same concept. We can pull data from other sources. We can post charts, take actions, send stuff back. We can also send stuff back to Ops Manager in the case where we need to do things like bounce servers or do minor version upgrades or do whatever action that we need to take. Guess I should have brought the clicker with me here. All right. Okay. So probably at the core of this was the little chat language we had to create. And I looked at using natural language processing and decided that was just way overkill. This is sort of intended to be used by techies. If there's anything we can do, it's pick up a new language pretty quick, at least a language that you type into a keyboard. So there's not a whole lot to the language here. There's a simple rule-based language, and I'm going to walk you through how a request is come in and transformed from a stream of text into a JSON request that then we can use to route to an appropriate rule. So first we do standardized replacement of words. So if I type in Ops Manager, I abbreviate that to Ops MGR, so I know that that's the value I'm going to see when I'm routing that request. Things like box or server becomes host. And so on. So there's a variant list in the utilities class here that will allow you to do that substitution for you. So you can sort of standardize everything to make your problem space much more simpler when you're trying to route that rule. Then we search for all sources, and these are just keywords. In this case, Ops Manager, to determine where to route the request. So if it's not present, there's a default setting that you can use, which we have set to Ops Manager. But if you have different sources, i.e. internal monitoring, New Relic, Sumo Logic, whatever else, you could add those as different sources. So I could specifically say, show me internal monitoring connections for this host, and it would only post the TCP/IP stuff. Search for an action, what the user wants, so connections. In this case, we only use the first action, so if I want a chart of connections and a chart of queues, I have to issue 2 different requests. So we can only do one thing at a time. That's a limitation. Info items, so things like hosts or replica set, and that's basically an information item. The word immediately or list immediately following that keyword is what we use to populate that info item. Finally, since most requests require an ops manager project or group name, that value is defaulted if it's not provided. Comes in handy if you're only running, 1 or 2 groups. Maybe you're only running dev, prod, dev, QA, and prod. Obviously, prod is going to be the one that causes you the most issues. Okay, so creating the chat language. Show me the ops manager connections for host DB, for box DB node 1. Connections is changed to con, which is the keyword we use. Box is changed to host. Extra words like show me and for just completely ignored. They're extraneous in our case. So now functionally, at least the request looks like this. Ops manager, which is our source. Con, which is our action. Host, which is our info item. So a list of sources is set to ops manager. The group is defaulted because we didn't specify one. The action is set to con. And an info item called host list for that particular host is added to the element of the array. So every request returns a host list. So the group ID is also automatically added because that's almost always needed for subsequent requests. Hosts are added to the host list using the results of that host endpoint that I showed in the command prompt window earlier. So you have all that information as part of your request. If a replica set is provided, we populate it with all the hosts in that replica set. If a list is provided, we just search to find the matches. So you can say hosts and then a comma separated set of hosts. I do permissive matching here, meaning that if you're running multiple MongoDBs on a server, which is not best practice and we would never recommend that, the first one it comes to, an ops manager would be chosen. So you may need to issue a port there if that's the case, but you can shorthand that. So node 1 27017 will find the host node 1.vagrant.local 27017. So all of that happens, and we transform that text that the user entered into a request to JSON that looks a lot like this. So we can see we have a group, the channel ID that the request came in from, the list of hosts, the source list, the ops manager group ID, and the action we need to take. So next we need to parse and route the request. We do that using the action field. If we can't find a rule, we let the user know. We post a snarky reply, as we saw before. So if something goes wrong, I just have this random list of snarky replies. We spit one back to the user. The routing is done in the actual mongobot.py code. So and here's basic example routing code, nothing too extreme here. If action is con, we call row connections.processChat. Action is lag, REPL lag process chat, etc. So I recognize a lot of faces. A lot of us were here for before. We have some more material to cover. So we talked about routing that chat request. So we parse that chat request using our simple chat language. We return a JSON structure. Let's go back a couple slides that looks like this. Then we can route that request to the appropriate rule. Okay. So we do that in the mongobot.py. So that's where MongoBot comes from. And then we have all these rules that we plug into it. So now creating a rule for the request. How do we do this? Well, each individual rule is going to be responsible for validating that all the necessary information, remember we talked about information items such as replica set, host, etc., is present in that request. So if not, that rule should respond and let the end user know that, hey, you're missing a piece of information for me to take this action. All action and communication should be done from the individual rule. So don't rely, the only time MongoBot actually responds back to the user is with that snarky reply when it can't figure out what to do. You can take actions for every action or every source, the source list is necessary. So ops manager, new relic, internal monitoring, whatever the case may be. And we'll see this, the example rule for connections, and this is the actual code that you'll be able to download. I'll provide you guys a link for it at the end. When I ask for connections on a specific server, basically we ask, if the ops manager is in the request list, then I do some validation looking for group and host list, etc. And then I just list I loop through those hosts in that host list, because if I specified a replica set, I'll have a whole list of them. Otherwise, I might just have one. I call that generate charts function. And then I post back, or I post a message saying there are no connections if no chart could be generated because they were all zeros. Not the case for connections, but we did see that example for queues, when we asked for queues on a server and we got back the response, there are no queues. Plotting the results gets a little more tricky. I decided to use the matplotlib because it's fairly widely distributed. It's Python, a lot of people know it. But the problem is when we pull the metrics from Ops Manager, they're in a format totally incompatible with what matplotlib wants to see. So you can see here, Ops Manager, we get this measurements array containing a data points array showing a timestamp and a value, and then the name and the units. What matplotlib wants to see is basically a list of arrays. So timestamp array and then a value array, as we can see below in the lower example. So I created a function, transform metrics, that you can just send the ops manager metrics into, and they come back out formatted for you to plot using matplotlib. Zero values can look ugly in charts, so there's a scrub metrics to remove the zeros so you don't get lines that do this. We can just post nice, smooth, pretty lines, especially when you're dealing with a chat client where you have a smaller chart space to plot. Sum metrics is another utility function out there that allows you to sum multiple metrics up into one single value. We do this for op counters because op counters come in like 4 or 5 different flavors. So the op counters charts we saw in the demo at the beginning are actually sums of several different op counters. There are chart settings too that you can use to alter the appearance. Most of the settings for everything, well, all of the settings are in the settings Python script. So you can change colors and sizes and the fidelity, or the pixels per inch, DPI for inch of the charts. There's another function, OM charts. This is where I've created each individual function. So there's like a gen connections chart, a gen replication lag chart. So that way you can reuse those charts from other modules. So like health check uses connections chart, connections uses connections chart, and so on. The omcharts.gen chart is the secret sauce there. That's what takes the data in that you pulled from Ops Manager or from your third-party system, wherever, and generates that chart. I don't have time to go through all the parameters there. They're documented somewhat in the code. Like I said, we'll have a link to download that. Just one thing to remember, that first parameter is ID, which is how we save that chart's JPEG file off to our web server. Needs to be fairly unique because it appends the current timestamp on the end. So we just use either the Ops Manager group ID or the alert ID, which is always present depending on what we're doing, to keep that unique. Okay, the chat API I'm not going to get too much into. In this demo, I've used Mattermost for one key reason. It comes as a Docker container, is contained on my laptop. So I do everything self-contained. I'm a little old school. I also live out in the sticks where internet can be spotty sometimes. So I want to make sure that if bad storm rolls through, my internet connection gets knocked out, I can still keep working. So, but Mattermost is kind of a Slack knockoff. So if you use Slack, a lot of the API calls will be very similar. Oops. Typically you call post methods to channels. You can create channels, add users. There's a bunch of different things you can do. So here's where we should have been at the break. Ops Manager API calling the Ops Manager API to get information or take action. We talked about the anatomy of the responses from Ops Manager when we issue a request. Ops Manager webhooks, so we send data to our REST web server when an alert is triggered. Then the chat bot, what are the components? What's the chat language that we invented? Parsing and routing those requests, creating rules for each request, plotting the charts, and a little bit about the chat system API. Okay, so the second half is a little bit less. There'll be a little bit more time for questions as well at the end. So respond to requests for information. How do we do that? Well, we have all the tools in place. We have a request. We have bits and pieces to plot things and to respond. So what do we need to do to put that all together? So the utils.parseChat request is called. We're ready for you in the code. And return that JSON request that we saw a few screens back. The routing logic is done by mongobot.py. We'll send a request to the given rule based on the action value, or post some snarky reply if it can't figure out where it goes. Each rule is responsible for validating all the data that's sent into it. Each rule should respond to all sources sent to the request. So if I have, Ops Manager, internal monitoring, sumo logic, I should have code to handle each one of those in succession, so that way I can post information from one or several or all of those depending on what's sent in. So typical information requests would validate the parameters, call Ops Manager. So we have this get Ops Manager metrics, generate a chart, post the chart and any relevant text back to the channel. And of course, similar actions would happen for other sources beyond Ops Manager. So we'll take a look real quick at that. We saw the rule code. I will show it again here. This is MongoBot here. Here's the chat bot piece. So when we have an action, we just it's just an if statement. The only thing we're really doing here is posting the channel ID into the request so we know from the rule where to post our response back. And then, of course, just a bunch of if statements to determine where we're going to send that request to. And of course, if we don't find anything, we just post that snarky reply back. One of the simple rules here, connections, process chat. So if I ask for connections, here we go. Just validate the source here is Ops Manager. Then we validate that we have a group and one or more hosts to plot connections for. And then just a few lines of code here. OM charts gen connection chart with a few parameters here. And then if we don't get a chart back, if we do get a chart back, we post the chart. Otherwise, we post a message saying there are no, in this case, connections to plot. Okay, responding to requests for action. Almost exactly the same with one little difference. Well, two little differences. One, you probably want to let the end user know what's going on. So we saw that when we did the restart. I said I'm restarting node 2. Node 2 restart complete, restarting node 3, so on. So it's good to inform the user what's going on. We always like to know that. And the other thing is the Ops Manager API does not control concurrency from multiple requests coming in at the same time. So you need to lock other requests out when this happens. So in addition to updating, I've created a lock class, and we just send the group ID in here, and it's just a simple file lock, but it basically prevents any other user in the chat or any other chat channel that's running on the same MongoBot from initiating a request at the same time, so you don't step on each other's requests. Things like the restart's very sensitive to this because the restart's actually, at a 3-node replica set, is 6 separate requests, so we need to lock everyone else out. Of course, the Ops Manager group ID is what you use to obtain that log because that's the granular level. So if you have multiple Mongo bots running against multiple Ops Manager groups, It's not such a big deal because it's typically group by group level where you need to lock out other users from making those changes. So, we saw upgrade, replica set, blah, blah, blah. We would obtain a lock, do our work, and then release the lock at the end. So we validate the parameters, obtain the lock. In this case, find the next minor version, which is just a little bit of code involved in there, or if it's sent in like we did in our example. Upgrade and monitor, keep the user in the loop. There we were monitoring for 120 seconds to allow the upgrade to complete. At the end, we release the lock, or we just give up and say, hey, I've tried for 2 minutes. I don't know if it worked. Sorry, Jack, you and your spouse are going to have to leave the restaurant because you're going to have to pull your laptop out and look at Ops Manager anyway. So hopefully that won't be the case very often. And of course, let the user know how it went. So responding to alerts. This is the alert hook we talked about when we saw that connections alert. Here's the overall flow. The alert data comes into our webhook. We call the connections alert rule. We open a ticket. We create a new channel. Add others to the channel. We join the alert, the ticket, and the channel together for use by that Mongo daemon to repost information. And of course, we post information right then and periodically over time. So open a ticket. I just created a stub function here. Utils create incident. Right now it's just inc plus timestamp. So you'd be responsible for writing any code in there. You send the alert and any optional text for the ticket in. There's a ticket server URL in the settings if you have a URL that you can talk to your ticketing systems with. The only caveat here, return that ticket ID from that function so we can later associate it with the code that we've written already. You can post other information to the ticket. We're in sort of a chicken and an egg problem. What do we create first? Decided to create the ticket first. So you may need to, if you wanted to generate a chart and post that to the ticket, that has to be done later, certainly after you generate that chart. Because only the alert data is available right when you create the ticket, but you can send that in. Okay. So the ticket is created first, so we can add the ticket data to the channel and the alert acknowledgement. So we create a channel. There's that chat post class. The create chat channel creates the chat channel for us. If you're using something besides Slack, you may have to rework that a little bit. We just posted the channel's endpoint with the channel data. We include the incident ID and the alert ID in the channel header so we can reference them later if need be. And we saw that in our chat client here. The chat name was actually the incident, but we could see in the header of the channel, incident and the alert ID is shown there. So you can actually reference that later should you need to, either manually or programmatically. Other tasks specific to Mattermost, I'll kind of gloss over these because if you're not using Mattermost, it won't matter, mostly. You have to add members of the team to the channel, in this case, all the team members that MongoBot's in the MongoBot team. We have to add a webhook in so we can interact with the channel. And in this case, we chose to add a word. So in the case of the incident channel, I had to preface every command with the word MongoBot, okay? If I can, well, anyway, I had to say MongoBot connections, blah, blah, blah. This is to allow me to interact with the other people in the channel. The MongoBot channel itself is really designed just to interact with MongoBot and not with other people, so we don't require that word, save the typing of MongoBot. So I can just say connections, host, yada, yada, yada there. Okay. So as I mentioned, the interactive MongoBot channel does not require that prefix. So respond to alerts, add members and hooks. As I said, you may need to manually add the new members. There's probably an API in your chat server to do that. Add that webhook so MongoBot starts listening in on the new channel for requests. And in this case, you can see at the bottom, In the actual code here, I have the trigger words Mongo and Mongo Bot in a couple of different cases there. So now we need to join the alert, the ticket, and the channel all together. So we have an alert, we have a ticket ID, and we have a channel ID. All those members are added so we can all collaborate, and MongoBot's registered to listen for requests so it can post information periodically. But we need to acknowledge the alert in Ops Manager, and we're going to add some metadata to that alert acknowledgement so we know what ticket number we're dealing with and what the chat channel ID is. So we use the acknowledgement comment to do that, and we just put in some text we can convert to JSON, incident and channel. There's that Ops Manager alert function that does that for us. Just a warning, do not manually re-acknowledge the alert. It will break that association. We don't have anything to prevent this aside from threat of bodily harm, which could be a valid policy. I mean, it is a policy. You could store this elsewhere in a different data store too, say a JSON schema database or something. But right now, we're just putting it in the alert acknowledgement comments. And of course, responding to alerts, posting info, we're using the rules just like we did before. Only create a ticket if the alert has not yet been acknowledged. So there's a parameter called isAct in these rules. You can call the rule repeatedly over time. Just call with isAct equals true, and it will just post the information and bypass the channel, the alert, the ticket creation. So, for example, our connections alert here. So we can see this isAct, we default to false. If it's not been act, then we create an incident. If we get a ticket back, we create a channel. And if we get a channel back, we act the Ops Manager alert, passing the alert, the ticket, and the channel information. Otherwise, if it's already been acknowledged, since the alert comes into us, we saw that JSON earlier in the anatomy of an alert, we can just load the comment, the acknowledgement comment, and pull the channel and the ticket right out of that acknowledgement comment. And then we post our information here. So we create our connections chart, and we create our ops counter chart. And I was creating a queue chart, but then I would have had nothing to type in my demo, so I commented that code out. So that's it for creating these functions to handle those alerts. But how do we call those repeatedly? Well, we need that additional component, MongoDB, to continuously monitor alerts and post information outside that normal webhook flow. So, of course, it's useful to periodically update the team. There's a setting that tells it how long to sleep. I think I've defaulted it to 5 minutes. Other functions may be useful when an alert is cleared. Right now, we're only looking at the open alerts. You could look at all alerts in this MongoDB and take other actions when an alert has been closed recently, such as closing the ticket, informing the channel, hey, this alert's now cleared, it's not there anymore, because you have the alert and the channel tied together, so you know that, oh, this alert goes to this channel and it's closed, I'll post that to the end user. Even close the channel if you want, or you could write a command to do that. So MongoDB right now will just go through all the open alerts, search for the channel and ticket metadata in the header, and refire those rules to post that same data. So we saw an example of that early in the presentation of the connections and the op counters being posted every few minutes automatically for us. And of course, you set the isAct to true, which prevents all that pre-processing of alert creation, channel creation and ticket creation up front. So, and of course, any other functions that you want to add in. So I wanted to keep in mind this is a framework. It's somewhat of a proof of concept. I intentionally made the code more easy to understand than making it, very tight and compact because a lot of things are the concepts here. So in review, we talked about responding to those user requests for information and for taking an action such as upgrading, restarting servers, and how we respond to alerts. In this case, creating a chat channel, filing a ticket, associating all those, that alert, that channel, that ticket all together so we can programmatically maintain that link, invite others to the new channel, and post some data for the alert. And finally, MongoDB, which can process open alerts and other functionality. Okay, so that's the end of the presentation. You may want to write down the, or take a photo of this here. So this code is up on GitHub for download. It requires Python 2.7 or later. And there might be some dependencies. I don't believe I had to install anything on my Mac, but that's not saying a lot because I have a lot of Python modules by default on there. So go ahead and you can pull the code, have a look. Any questions, comments? Do you guys think this is something that you might be able to use in your organization? You think it might save a marriage or two? I know, I get that all the time, Why are you looking at that phone? Well, there's an issue going on. So anyway, that's the whole point. It's to, sort of be able to allow you to free up, at least when minor things happen, not having to stop what you're doing and miss out on your family lives just for something like a connection storm or something that can be easily fixed elsewhere. All right, well, thank you, everybody. I'll be out front door if you have any personal questions.